It's science time. 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 It's so much fun. Learning fun for everyone. Everyone. It's science time. Yes, yeah, best believe. Explore and learn new things. Here with Mr. C. It's science time.
Hello children, good to have you back. Teacher Charisse here again for your science class. Before we start our lesson, we'll have this first.
In your search engine, simply type learninggames.com/motion-games/letterfall.html and click enter. Then you can see that the website will display this game. So the title of the game is Letterfall. So what you're going to do, just simply click the word play. So here you can see the game.
Use the left, right, and up arrows on your keyboard to help the mouse catch the falling letters and correctly spell each word.
You can hear the directions there, so simply use
Motion is a change in position or
arrow.
location.
So you're going to spell position, so you just have to catch letter P. Oh my goodness. So you can jump using the up arrow. So position, you're going to spell position E-O. Then you're going to S. Then I. Then you're going to wait for letter T. There's that. Again, you can jump using the up arrow. You can move left and right, up. Then I. Then you're going to catch O. Then you can jump, then letter N to complete the word position. Now,
Circular.
I'm going to give you time
I went in a circular motion on the merry-go-round.
to work for this game. I'll give you 5 minutes. How did you find the activity? I hope you enjoyed it. In playing football, how do the players play the game? Good. Of course, they kick the ball. Why do you think they need to kick the ball? Of course, to move it. What do you think they applied to be able to move the ball? If your answer is force, you are correct.
Force. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean? Let's go back to our first example of this video. Here, in order to pass the ball to his teammate, the player must move it. That is, he must interact with the ball to move it in the direction of his teammate. He interacts with the ball by kicking it. The ball and the player interact with each other. In the second example, in order to move the desk from point A to point B, he must interact with the desk. We will study more on these interactions in the future videos. Now, since we are clear with the basic understanding of what force is, let me put its definition in front of you. It states that a force is a push or pull upon an object resulting from the object's interaction with another object. In the next lesson, we will talk more about these interactions. See you there.
Okay, so what do we use or exert to make an object move? Right, we use force. So again, force causes an object to move. So all motion is due to forces acting on objects. So we use force to move an object, and if the object will move, we call that motion. So again, what is a force? It is a push or a pull. So motion, we know that it is moving if there's a change in the position of an object over time, and we call that movement as motion. So how do you know something has moved? So you will have, or you will use, a reference point. When we say reference point, it is a stationary object. Stationary means it is not moving. So example, in this picture, you have here the tree and the beaver. So what is the stationary object here? Yes, the tree. The tree is not moving, so it is a stationary object. When you see the beaver move, when you look at it again, and if it's moved to the right, meaning it is moving. There is a motion because there's a change in the position of the beaver. So how is force measured? Scientists measured it in Newton. Okay, it stands letter N, from Isaac Newton. So the more Newton, the greater the force. So one tool to measure the force of gravity is the spring scale. You can see it in the picture. So examples of forces. So we have what we call the visible forces and the invisible forces. When we say visible forces, we can see it, while invisible, meaning we cannot see it with our eyes. So example of visible forces is when you use your fingers to open a book. Another one is you push the buttons on a keyboard. Those are visible forces. You apply forces. Invisible forces, on the other hand, here are the examples. We have gravity holds up a chair. So we cannot see the gravity that it's holding a chair. And another one, two magnets coming together. Another one, the force that results from combining forces. We're going to discuss that later on our lesson. So the total combination of the forces acting on an object is what we call net force. So is it possible that there will be more than one force acting on an object at the same time? The answer is yes. So if you can see it in the picture, so the boy is pulling the dog. So the forces here is gravity is pulling the boy down to the earth, the ground is supporting the boy, and the legs moving forward as like you are running during your PE. So there are more than one forces acting. We're going to discuss gravity in the next lesson. So how are we going to measure net force? So there are different ways to measure net force. If you are using same direction as in the picture of these two person pushing the car, if you're going to exert force on the same direction, you're just going to simply add them together. So example here, person number 1 is exerting 20 Newton. Person number 2 is using 20 Newton to push the car. So you'll have to add them up. So 20 Newton plus 25 Newton will give us exactly 45 Newton. that 45 Newton now is the net force. How about if there is an opposite direction? If we're going to exert our force in opposite direction, as you can see in the picture. So you have here team 1 and team 2. So these two teams, they are pulling the rope in different or opposite directions. So team 1 is pulling it with 25 Newton force, while team 2 is pulling it in the other side with 10 Newton only. So what you're going to do, if it's opposite direction, simply subtract. So 25 Newton minus 10 Newton will give us 15 Newton. This 15 Newton now is our net force. So unbalanced forces produce motion. Let's have it on the next slide. So balanced forces, when we say balanced forces, the same force that you applied on the object, as you can see in this picture. So a balanced force is one in which the net force will be equals to 0. So here you can see they are exerting different or opposite direction, but they use the same force. So 25 newtons and 25 newton. Do you think if they're going to exert the same force, there will be any movement or motion? Of course, no. So these two objects, or if they're going to exert the same efforts, there will be an equilibrium since the forces are balanced. Next, how about if we have unbalanced forces? So an unbalanced force is one in which the net force is greater than 0. So example here, these two examples in the pictures, we have the first one, this one, the tug of war. So different team exerting different forces in opposite direction. So team 1 in the purple shirt, they're exerting 25 newtons, while the other one, the blue team, they are exerting 14 newtons. So what do you think will happen? Will there be any motion? Of course, yes, because they are applying unbalanced forces. But where do you think is the direction of the force? Right, to the right, because they exert more forces. But what will be the net force? How do we get the net force of this? Yes, you're going to subtract because they have different forces. So 25 minus 40, or 40 minus 25 will give us how much? 25 newtons. So 25, the right team will give us 25 newtons more. How about the other example in the picture? This one, the two. So there is a gravity pushing them 2 newton, while the other one is 50 newton. So what do you think will happen? Will they go up or will they go down? Of course, they will go down because it exerts more effort in pushing them down. So what do you think is the net force? So we'll just simply subtract it. So 50 minus 2 will give us 48 newtons. Nice. So only an unbalanced force can change the motion of an object. So example here, you can see your doggy can cause you to move if he pulls with enough force. So you can see here, one dog can have a force of 18 newton and the other one is 18 newton. So if you're going to add them, they will have 160 newton. So what will be your force? What do you think will be the force so that the dogs can move you? So it will be below 160 newtons. So his force is greater than the force you're using to stay in place. So what would happen if an unbalanced force acted on an object that's already in motion? So example here,
Your sister is driving her car. You ran up behind her and give her a push. So what will happen? Your force will add to the existing force, causing here or her to speed up. So there will be a change in the speed or direction of the object. You will go faster or it will make you slow down. So unbalanced forces can act in the same direction. Okay, example, as you can see here. You're pushing a cabinet across the room with a force of 15 Newton, while your friend is pulling with a force of 10 Newton. What do you think is the net force? It is in the same direction. What direction is the cabinet moving? Yes, to the right. Okay, because they are using the same force in the same direction, we're just going to add them up. So the net force will be 25 newtons. So unbalanced forces can act in opposite direction. So example, we have here 6 people are tugging on a rope. So 3 people pulls with a force of 20 Newton to the left and the other pulls with a force of 25 Newton to the right. So what do you think will be the net force? This is now in opposite direction. Take note of that. So if we have opposite directions, what we're going to do is simply subtract the forces. So 25 newtons minus 20 newtons will give us 5 newtons. That will be the net force. And what direction is the rope moving? To the left or to the right? Correct. It will go to the right. Okay, team on the right will win in this game because when you have opposing forces, the direction of the object moves in the same direction as the larger force.
Let's see if you understand the lesson. We'll have an activity. In the address bar of your web browser, type learning-of.com/kindergarten-science-learning-game-push-pull/ and then click enter.
Okay, this game
Is what we call tic-tac-go. So if you don't know how to play tic-tac-go, this should supposed to be 2-player. But if not, you can only play by yourself to try if you understand what is a force. So again, force is either push or a pull. So you can use player 1. As you can see here, you can have X and then O. This is what we call tic-tac-go. So it is an interactive game. So click where you would like to place your tile and then answer this question for each picture. So here you can just click to enable Adobe Flash Player rather. So just click it, then allow. Then it will display here. Okay, then just click begin. So player 1 X, player 2 O. So you can play this with a friend, with your parent, or with your brother or sister. So first tile, first player, so X. So you just have push or pull. So what is this? So answer is push. Okay, so player 2 should put O. Then you choose whether you will have to tick this tile, this one, or this one. If you can make a vertical line, horizontal line, or the slant with the same symbol, either O or you will have X.
for example, you will win this game, or you will be the winner. So example, if I can answer this tile, push or pull. So the horse, you can have this arrow. This will be your symbol to know whether the force is push or pull. So this one, the horse is pulling. Okay, so that is X. So now player 2 will play. So I am planning to complete this task. So I will click this one, push or pull. So this is pushing. Then X, I am planning to complete this one. If you are player number 2, or you can have this one to complete. So if you're going to tick this one, push or pull. So you are pulling. So X, correct. Now I want to complete this one, so I will win. So I'll take this tile, push or pull. The arrow is going there. So you are pushing. Okay, so player 2 won this game. So I'll give you 5 minutes on this one. No, I'd rather give you only 2 minutes because this is very easy. Okay, ready? Can start now. Here's an additional exercise you can do at home. That's all for today. See you again next time. Bye.